Good to see you today.
Yeah, I think it's fantastic to catch up with you again.
Yes, wonderful.
Yeah.
So I know everything about you. Tell us a little bit more about yourself so that people know more about you.
Sure. So I'm an engineer. I did my engineering from NIT Jamshedpur.
It used to be
Subsequently,
REC those days, or was it NIT?
it used to be called RIT, which is very
RIT.
unique.
Wow.
It was a regional engineering college, but the nomenclature used to be Regional Institute of Technology.
Wow.
I think it was one of the first few RECs which were established in India, and had a wonderful education over there. And then, of course, I joined Ashok Leyland. I worked in their engine research division for close to 4 years.
Wow. Did you guys ever think that electric motors would come in and your research would not would not be that sought after?
No, even at that point, we knew electric vehicles were coming, and in fact, even on diesel engines at that time, the Euro 3 norms were being implemented in India. So there were electronically controlled units which would govern how much fuel would go into the engine. So we were exposed to a lot of electronics, a lot of electrical systems even during those times, and we knew that at some point of time, things will go electric. Although full electric is still a pipe dream.
And did you get a chance to work on the hydrogen engines?
There were discussions on using hydrogen as a fuel. There are certain limitations because it's a much more explosive gas. The combustion process takes place much faster. So the shock that would be sent through the engine would mean that we would probably have to build stronger engines or reduce the power output for the same engine configuration, right? But this was in discussion even during those times.
But that would be a truly clean fuel, because electric is not that clean because we're using lithium-ion batteries or some other component.
Yeah, I think we need to separate out the propulsion due to from electricity and the storage solution, right? Since electric vehicles are mobile units, and currently, we generate electricity, either burning fossil fuels or through solar panels or through wind and hydro. A little bit of electricity is produced from nuclear fission reactors, right? And these are supplied through a grid. And since there is no continuous connection of these electric vehicles to an electric grid, we still haven't figured out wireless transmission of electricity. So therefore, we need a storage solution so that we can store electricity and use it as and when required. And of course, storage itself comes with its own challenges in terms of mining, in terms of pollution. So it's plus there are limitations on the side of chemistry as well when it comes to.
I think there's a lot of work which is happening around that area.
Yeah.
So what did you do after Leland?
So after that, of course, I did my master's in business administration from Indian Institute of Management, Ahmedabad.
Wow, so you're an IMA grad.
Yes, of course. And then, of course, I joined a real estate consultant, Jones Lang LaSalle, worked there for 2 years. And then subsequently, I started up on my own. It was, decently successful. Then I sold off my stake. Then I consulted with various startups, and I think there was a stint when we ourselves, worked, going to colleges, universities.
But tell me one thing: why do all engineers leave engineering?
I can't speak for everybody else, but I think for me, I felt as if I wasn't working at the cutting edge of research, even with respect to diesel engines in which I was working. And I felt a sort of disconnect. And end of the day, we are all competitive, people by nature. We want to try to be the best at something. And when you see that you're not at the top in terms of research in that field and things like that. So and I was always good in with presentations and communication. So
But then why would you do engineering if you had to do an MBA?
I was very clear why I wanted to do engineering. It was my dream to, get into competitive sports.
Wow.
I was very inspired with Formula One. I used to follow it regularly, and in a certain way, my dream was to be a mechanic with one of the Formula One teams,
Wow.
and that was the reason why, I took up.
So what are you doing about your dream about, studying engineering, or, what you studied first?
Yeah, so I think about a year back is when I took a break, and I really wanted to understand what exactly is it that makes me happy from the inside, right? What exactly gives me joy? Is it business? Is it running or chasing those dreams with respect to how much money you're earning and things like that, or was it science? And I never lost touch with science per se. I would always keep abreast with what is the latest happening. Probably I would go into a little more detail than the average person in terms of what exactly is happening. And somewhere I realized that this is really enjoyable for me. I really love the
What are you
process of.
doing which is different now?
Yeah, so I think what I have worked on is to separate the theories from the observations. Uh, so today, the observations and theories are so enmeshed, and despite that, there are a plethora of observations which prove all the theories, either partially correct or incomplete or incorrect, right?
Give me an example when you say partially correct or incorrect.
Yeah, I think let's talk about this phenomenon called Dropner wave. Okay, so Dropner wave, is a rogue wave which occurs in the seas and high oceans, and for I think close to 50, 60 years, sailors would always complain that their ships were damaged because of a rogue wave. And for 60 years, scientists denied the existence of these rogue waves because, as per their mathematics, uh, you know, no wave above 30 feet can, arise in the oceans. This was what their math said. This is what the theory said. It wasn't until it was finally captured on a camera on an oil rig that they, accepted that, such rogue waves could, exist in the ocean.
And why do they occur? Is it because of the climate change? Is it more frequent now, or it's just a phenomena on the sea?
Yeah, so now there are two theories that they have propounded as to how rogue waves could arise. But I think this is a challenge we are facing, right? For one observation, probably today we have two or three theories to explain it. You take the example of something as fundamental as gravity. You have the Newtonian classical to its evolution to the Einstein's special theory of relativity, and then you have quantum gravity model as well. So it's the same phenomena, but then there are two completely
That's
different
the joy of
explanations.
science. There's discourse. You can debate. There are alternate views, and may the best win. So what's the problem with that?
Oh yeah, I think that's a sea change that has happened, right? Because if you look at medieval times, we believed that Earth was the center of the universe, and the challenges that men of science faced during that time when they used to talk about new ideas are completely different to the challenges that we face today. So in that respect, I think we have come a long way. We are able to sit across over here, and talk about different ideas, different concepts, and there's nobody, who's going to deny a right to speak out on these matters. But I think where we have stagnated is we don't have answers. Right now, even if you talk to the best of scientists from any field, even they would accept that even though we have come so far, there are still several things that need to be answered. So while everybody knows what the challenges are, I think the solutions are missing, right? And there could be a number of explanations. However, they have to stand the test of predictions. Can you explain things, give a mathematical framework which can be used to predict the outcome of a system? And I think that is where I think we are falling short.
What is in it for you? Why would you do this? Because in the field of science, especially
Yeah.
when you're doing pure research science,
Yeah.
right? The results are like 30 years, 40 years away.
Yeah.
I'll give you an example. The person who invented GPS, we don't even know about them,
Yeah.
right? I'm sure you won't be able to name the person who invented GPS.
Yeah, I can't.
Yeah, but
Yeah.
we're using it every day, be
Yeah.
it your now cab hailing services or your payment services, you're using GPS.
Yeah.
They alternates in different parts of the world,
Yeah.
but basically the technology is same. So why would you do something which doesn't bring you fame?
Uh,
Or maybe it'll bring you fame when you're 30 years from now, or maybe never. Why would you do that?
Yeah, I don't think fame is something that I'm chasing.
It won't even get you money, because I'm sure the inventor of GPS didn't make money if there was no commercialization.
See, it all depends on how fundamentally you are able to alter the outcome for human beings, right? So let's talk about some of the challenges that we are faced with today, right? And I think this is where a lot more effort needs to be forthcoming from the scientific community. So today we are faced with challenges of climate change, right? Today our energy mix is still 80% fossil fuels. Even though there has been significant investment in renewable energy, I think 20% is just doesn't cut the ice. And I think every kilowatt that is going to be produced in the future, even there 40% of the needs are met with renewables. So what about the rest 60%? That is still going to come from your fossil fuels. Of course, even in fossil fuels, I think people have started promoting gas as an alternate because of the cleaner emission cycle, right? So some fundamental challenges in terms of our energy mix. How are we able to generate the energy which will of course be needed to power all the electric cars?
Why can't we possibly let's say 200, 300 years from now possibly create a mini sun, because that's the most closest form of energy which we see every day, and it's like almost infinite in like it could take a few billion years to extinguish itself. But or you could go nuclear, right? So
Yeah. So incidentally, that's where most of the focus is going to be. But you have to understand that you need to be very clear on the fundamentals of how exactly the universe is governed. What laws govern the universe, and the most fundamental is gravity. So even your quantum model or your classical models are not able to explain gravity completely, right? So the key lies in gravity, because this is one of the most powerful fundamental forces that exist in nature. So you will also have to look at the history of our attempts. It's not like we haven't made a genuine attempt at trying to create energy using nuclear fusion. So we have been able to recreate temperatures which are 6 times the temperature which are predicted as per the current theories at the center of the sun. Pressures we probably haven't reached very far. So if we have been able to recreate the conditions that exist at the core of the sun in terms of temperature, in terms of pressures, and yet we are not able to create sustainable energy. Perhaps it is time for us to relook at some of our theories of how exactly the sun operates, what exactly are the processes that
oil
go on
will
in the
not
sun.
go out of fashion because it runs countries.
Oil will run out eventually.
It doesn't seem so, because
yeah.
they are continuously finding new places where they can drill oil, even though it may be deeper, even though it may be environmentally more damaging, like the fracking what they're doing, but they seem to be finding oil.
Yeah.
And you're looking for billions of dollars where you could just possibly drill, and there's a whole engine and ecosystem which runs on it.
Yeah, so there are two aspects to this, right? One, is it an infinite resource or is it a finite resource? So if you talk in terms of finite or infinite, I think you have to look at time scales. Probably in the next 200 years, we'll never run out of oil, and we can continue drilling and digging it up and burning it. But if you look at larger time scales, I think that is where the challenges arise, right? And then if there is a sudden drop off, sudden dip in the production of oil, and oil is the major source of your energy production, then you're
But
looking
see,
at a
there are
huge
other
challenge.
pressing
The other
challenges, right,
aspect,
in
the
the
other
world.
aspect of it is, of course, the emissions and the pollution, that come along with it.
But electricity isn't clean either.
Electricity per se is clean. It's what we use to create that energy
Look
that
at
is
India, 70% is coal based. Right.
yeah.
So
So
it's
this
not
is
clean.
yeah. So this is the challenge that we have to solve, right? Even coal is one of the major sources of producing electricity worldwide even today, right? Close to, I think, 30 to 40% of our energy still comes from coal. But we all know the where it is leading
So
to.
whether you're
Yeah.
burning, petroleum
Yeah.
or you're burning coal, both are, fossil fuels and polluting.
Yes.
You produce electricity either from coal and then you pump it back into an EV car. How clean is an EV car? Because you're using coal.
Yeah, so this is the big challenge, right? As I said, electric cars by themselves do not generate electricity. Uh, we have to generate electricity.
At the point of consumption.
Store it, in batteries in electric vehicles, and then consume it as we go. So even though electric cars are very efficient in terms of electrical to mechanical conversion, but the source is still 80% fossil fuels, and renewables are picking up, but even they're not able to keep up with the
And
demand.
so what are you planning to do around clean energy and engine combustion? What are you planning? How do you see this field changing
Yeah,
in energy?
yeah. So as I said, it's all about relooking at our assumptions and our understanding of the universe. So even when you generate electricity by burning coal or fossil fuels, you have to understand that there's a turbine which rotates, and then that is connected to a generator, which is basically a magnet and coils of conductors, right? So now, what exactly is the process by which electricity is generated? Because it is not per se the conversion of your fossil fuels which is creating electricity. The coils are rotating in a magnetic field. There are laws, which say how much electricity will be produced. And so, where does this electricity come from? The magnet remains the magnet, the conductor remains the conductor. So, we are already producing electricity out of thin air. It is, see, we have various ways of producing this electricity today, right? Solar panels convert your radiation directly to electricity. You have the thermocouple effect, whereby, a temperature gradient can create electricity.
But the question is, can this be created at a scale at which we consume it?
Yeah, I think that is where the challenge is, and that is where science has to, really
So there's
evolve in
geothermal
terms of
energy,
understanding.
there's energy which you can produce from the sea waves. There's solar.
Yeah.
The solar, if you want to do solar,
Yeah.
the solar farms take. They're
Yeah.
competing with agriculture.
Yeah.
You can put wind turbines.
Yeah.
But can you produce it at a scale is a question.
Yeah, the biggest challenge with renewables is the storage, because they are intermittent in nature. Right, you have day, you have night. So solar, you can probably have 9 hours of electric supply. So what happens during the time when you're not generating? So you have to store the energy in some way or form, right? It's the same with wind. The wind is not constant. It varies. So the challenge with renewable today is that it has to come with a substantive storage solution, and storage, of course, is the biggest challenge facing our adoption of electricity everywhere, be it electric cars, or mainstream production, but nuclear fusion was touted to be the answer. If we can recreate the processes of the sun, this solves all our problems, because the sun never.
And it's there. You
Yeah.
can see it. There's
Yeah,
a living
yeah.
proof for it.
Yeah. So
That didn't take off, possibly. Or did it?
It's not a question of taking off per se. I mean, listen, at some point of time, we have to take a backseat, right? And say, okay, we believe that this is how the sun works. We believed it for 100 years. And just like we believed that the earth was at the center of the universe. What if we are wrong, right?
So are you challenging what people understand about sun?
Yes.
What's your base?
Okay. So, what are the four big questions that still remain unanswered, whether be it quantum or be it the classical fields, right? It's still gravity, it's still dark energy, it's still dark matter, right? And even though the forms, are more or less the same. For example, in the quantum, you have the SU3 symmetry, you have the SU2 symmetry, and the U1, which is a strong, weak, and the electromagnetic, interactions. In the classical, you have this whole force and acceleration paradigm, right? While Newton thought that all the planets were somehow connected by a string. This is how we visualized force. Einstein came and said, it's a fabric. Why can't we move beyond that and say, could we treat space as a quantum field with fluid-like properties?
It's an opera, possibly.
Oh yeah, 100%. So the way I look at it is, let's say you want to create symphony, and the symphony is the way the universe works. You want to understand the symphony. You want to understand what is the song to which the universe
It's dancing
moves,
to.
right? And then you have this whole sea of observations, right? Can you imagine Einstein playing with the plethora of observations that we have? Would he come to the same conclusion? Right. So now, if you let go of the theories, which are limiting in a lot of ways, and you just look at observations and you arrange the observations in the right way, you have to answer each and every of those observations. So, for example, the biggest challenge for any model of gravity is to explain the superrotation. I don't know if you're familiar with superrotation. It's basically when the upper atmosphere rotates faster than the planet. How is it possible if it's a smooth gradient, as Einstein said? How is it possible if there is a string? Is there a dip in the string? How is that elasticity coming into picture? So maybe we have to relook and think: is it the Earth which is making the space around it or the air around it spin, or is it the air itself which is making the Earth spin? Right?
That's very interesting.
So can you imagine a single observation, which you have so far bucketed in climate sciences? When you bring it, to classical physics and you ask people to explain, the
falls
only
apart.
explanation that sounds viable is that it's a space which is, making things rotate, and rotation and spin we see them everywhere. You look at galaxies, you look at stars, you look at our solar system, and yet none of these theories actually, talk in depth about why this rotation takes place. So, there's a lot that needs to be
just
explored.
summing up, so what do we look forward from you in the next 1.5, 2 years? You've already challenged that fusion doesn't work. You're questioning, whether the air is spinning the earth or the earth is spinning the air. And it is great, if you can have a discourse on it. So what are we looking forward from you in the next 2 years?
Yeah, I think if we drill down to it, I believe it's possible to recreate the process of the sun. It's possible to create clean, sustainable, renewable, and an infinite source of energy is available. It's just a question of understanding how exactly the universe works. And as engineers, it is up to us to use our innovation, to use our creativity to figure out the best and most efficient way to.
So is Amit Krishnan saying we'll have energy on tap, like water?
100%, for sure.
And it's clean?
Yes, it's possible.
Tesla tried it, but he never made it.
Probably if Tesla had the money that he wanted, we could have been living in a very different world.
Maybe. But thank you so much, Amit, for your time, and it's glad.
No, thank you so much,
glad you took time for it. Thank you so much.
I think wonderful conversation, and as usual, it's always
we'll continue
great to
this
catch up with
series,
you.
and thank you.
Sure. Thank you.